Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 114th of physics, and in today's lecture we will discuss the determination of the resistance of a load. Before doing it practically, let us concentrate on the mathematical form. This will tell us that how many devices we are in need. There is a very famous law of Ohm which is saying this, that V is equal to IR. Now, from this we can derive this law, R is equal to V divided by I. If we want to find the resistance of a load, we will need two values of potential difference, which is V, and the value of I, which is current. It is written here R is equal to resistance, which we are going to find. V is the potential difference across the load. I is the current flowing through the load. So this equation is telling us that we will need two devices. One is voltmeter and the second one is ammeter. You also learned in the previous lectures that voltmeter is always connected in parallel while ammeter is connected in series. So if we want to determine the resistance of a load such as an unknown resistor, or we can set up a simple circuit using an ammeter and a voltmeter. The ammeter is used to find the current flowing through this load, and the voltmeter to find the potential difference across this load. The resistance of this load can be calculated using the definition of resistance, and that is written for you. R is equal to V divided by I. So the ratio of voltage to current is giving us the resistance. Now, to determine the resistance of a resistor using a voltmeter and ammeter, we have to set up the apparatus according to the given circuit in the diagram shown on your screen on the right side. Remember that in this case the resistance must be of low resistance. Now, what apparatus we are needing? Voltmeter, ammeter, variable resistor, accumulator. What is accumulator? I have written a definition for you. An accumulator is an energy storage device, a device which can accept energy, store energy, and release energy as needed. And in this case you can take it as the capacitor. So we will need an accumulator as well. Now, first of all, there is a variable resistor here. Through that we can adjust the value of resistance. So the second one is adjust the variable resistor to allow the smallest possible current to flow in the circuit. What does it mean? You have to adjust the resistance as high one. So when there is a high resistance, few electron will escape from the barrier, and as a result we will get a small current. Note the ammeter reading I and the voltmeter reading V, and note it down. Now in the second part you have to adjust the variable resistor to allow a larger current to flow in the circuit. Now, how you can do that? You can do that by providing a small resistance. If the value of resistance is small, many electrons will escape from the barrier and will flow through the conductor, and as a result we will get a large current. Again, note the value of V and I. Repeat the above procedure for 5 set of I and V reading and then take the average, so you will get a very precise values. Now then we have to plot the graph V against I. Remember that I will be on the x-axis and V will be on the uh, y-axis. Gentlemen, let me tell you one thing more here, that if a line is a straight one and passing through the origin, then this represents a direct relation between the two values. So resistance will be constant if voltage and current ratio is the same, means constant. You can find the value of the resistance by drawing a perpendicular 90-degree line. This is known as run and this is known as rise. So you have to find these value and find everywhere. If you are finding this value, you are not restricted to a particular part. Everywhere you will get a constant value. This straight line is showing the constant value, so the gradient will be after load R will give us the resistance. Result of this will be the gradient of the graph gives the resistance of the load R. So that was the whole story about finding the resistance. First of all, you have to uh, find the value of V and I by low current and then by high current, and then in that case we will be getting the gradient, and from the gradient we can find the value. In the next topic, that is very important because I saw many questions on the current voltage characteristics for filament. There are many uh, devices discussed here, but only this one is asked many times, but it is not known. That might be they are asking that which current voltage graph shows the characteristic for either filament lamp or pure metal or p junction diode or thermistor. So there are different. One thing is common in all these graphs, that a straight line is passing through the origin. It is here as well, and it is here as well, here as well, and here as well. So all these values of the graph will lead us to a very important law, and that is Ohm law, very famous law of electricity and magnetism. So the next topic is Ohm law, but before that let us discuss these different graphs. The first graph of the voltage and current ratio is for pure metal. In the pure metal, you can see that it is a straight line passing through the origin. So this is showing that the resistance will remain constant whenever voltage and current ratio is the same. Remember that voltage and I are potential difference and current. But one thing you must have to understand that the temperature must remain constant of the conductor. If the temperature is not constant, then you will see a different type of graph. So here I have written in the first graph about the pure filament, the graph between V and I for a conductor is a straight line passing through the origin. So it is a constant one. Now for the second part, we have written semiconductors. There are conductors in which there are many free electrons to flow. There are insulator in which there are no free electron to pass through the conductor, but there is another third device. Sometimes it is behaving as a conductor and sometimes it is behaving at, as a insulator. uh, Semiconductors are devices in which we are having both the properties of insulators and conductors. So sometimes it is conductor depending on the situation. But there are two very important technique we are using, that it is forward bias and reverse bias PN junction. So donor or acceptor are there. Because PN junction is not the part of this course, so we are not going in the detail. In my next course you will understand the biasing technique in greater detail. Here the positive y-axis will be taken in milliampere, while in the negative we will take it as microampere, as it is shown here in direct. This is the breakdown temperature and this is also the breakdown temperature. These two, it is passing through this origin, and this is the operating region in which this PN junction diode is working. The VI curve is a straight line passing through the origin. An electronic component may exhibit linear characteristic only in a particular region. For example, a diode has a mostly linear behavior in its operating region, which is this one. It is a linear one. You can see that this region is a linear one. Now the next one is a filament, and you can see that in the filament that is also a straight line. This is the trend line, but after some time when the temperature is high, the filament is showing that the current is reducing and the voltage, the current is remaining almost the same and voltage is decreasing. So till this area it is showing us that this is a constant value for V and I. The only difference between the two curve is that of what? That is up, that here the curve is coming down and here the current is increasing. So the I value is increasing and the I value is decreasing in the filament lab, and in case of thermistor uh, this is the current is increasing after some time. So till this area they are showing us the linear behavior. So here also the behavior of this trend line is a straight one. Here the trend line is a straight one as well. So these are the different characteristic of various materials, and that is leading us to Ohm's law. Tomorrow we will discuss the Ohm law in a greater detail. And uh, thank you very much for your times. Have a nice time. Allah Hafiz.